It's the ERP Confab. I'm David Essex, industry editor at TechTarget's ERP site. By one measure, buildings account for 41% of U.S. greenhouse gas emissions. Virtual representations of buildings, digital twins, could be a good mechanism for reducing their consumption of energy and natural resources and helping to decarbonize the built environment. A white paper from the Digital Twin Consortium issued a call to action to the architectural, engineering, and construction community to adopt digital twins. We'll hear the case, learn about the technology, and get practical steps from two of the authors, John Turner and Anil Sawhney. The white paper that you and the other four co-authors wrote for the Digital Twin Consortium is called Decarbonizing the Built World, a Call to Action. Why did you feel the need to publish this call to action at this particular time?
There is such a lot that has been published in the general press about the global warming and about our use of energy. And we felt that having been involved in the digital building life cycle, there was a lot which could be brought to bear in terms of transforming our industry to do a much better job at reducing the total energy use, the total carbon use within our built environment.
To add to that, I think John really put it very clearly, our interest in writing this. But we have also seen a lot of targets, policies, and regulations coming into play with not much connection to the actual action that professionals who are practicing in this business, delivering projects and running these assets could take. So it's really, therefore, call for action. We all know that the built environment sector is contributing about 43% of the global emissions. And there is deep interest in ensuring that decarbonizing the economy, the path runs to the built environment sector. So we do have to act now in order to address this. I think last week, the IPCC has released their assessment report, 6th edition, which shows that we perhaps not doing that well in terms of our targets, and they highlight the role and importance of the built environment sector.
Why are digital twins so important in this effort?
Really, there's two very important parts of digital twins. One is that digital twins can correlate information from a vast number of sources, but probably the most important aspect of a digital twin is it can compare real performance with what the performance is predicted to be. Sometimes I use the analogy of you're driving at 30 miles an hour. Well, so what? If you were 30 miles an hour on the freeway, you're going too slow. If you're 30 miles an hour within a built-up district, you're going too fast. Mm-hmm. So just measuring what you're doing, we felt was not enough. We had to bring together the predictive tools, which are a key part of a more advanced form of digital twins, so that we could go into closed loop analysis and really find out not just how we were performing as an industry, but suggest ways in which we could improve that performance and provide some practical instruction as to how to make those improvements.
And David, to just add to that, and we mentioned this in the paper, closed loop system is really what a digital twin is. It helps take a physical asset, connect it to its virtual representation, but connected bidirectionally. So it becomes a closed loop so that you can gather data about the performance of that asset and then run physics-based simulations and produce some insights which then decision makers can utilize to make decisions about the performance and fine-tuning of that performance for that asset. So that closed loop system really is one of the benefits of using digital twins.
What is a performance-based digital twin exactly? I think you've touched on some of the characteristics probably, but how does that differ from other digital twins? What does it do that's perhaps unique?
I think the key aspect is that a digital twin has to be aligned with a use case. So a digital twin, for the sake of building a digital twin, provides very little value to an owner. So we always align a digital twin with that use case. And in terms of a performance-based use case, we want to be able to predict the performance of the building. We also want to predict the performance of our individual projects to improve energy conservation. So if we don't have a way to build that out into a performance space, first of all, we can't predict. And secondly, we can't measure whether that performance is in line with prediction, and so make changes in the most beneficial and the most economic manner.
And the performance framework that we propose in the paper is really tied to a flexible, scalable outcomes framework. So you, as, let's say, the asset owner or operator, decide what is important to you. Is it the comfort and health and productivity of the occupiers? Is it the operational carbon or energy use? So you define that outcome framework, connect to the performance, and then utilize the closed loop system that a digital twin provides and make it measure, manage, and improve those outcome measures that you've identified. So we really are saying, don't build a digital twin just for the sake of it. Start with that end in mind, have the outcomes framework connected to a performance, and then connect it back to the digital twin.
So the paper contains a lot of information, and so some of the answers are in there. But for the benefit of our listeners, I'm wondering if you can go into a bit more about decarbonization. So decarbonization of the built environment is the goal here. Where does the carbon come from in buildings and maybe related infrastructure, and how can performance-based digital twins help reduce it?
There are really two main classes of carbon. Call them embodied carbon and operational carbon. And those can be broken down according to greenhouse gases into scope 1, 2, or 3. So scope 1 is focused very much on the building. Scope 2 is focused on the energy supply to the building. Scope 3 more on transportation. So in terms of embodied carbon, we're looking at all the energy which is consumed in the materials for the building and the construction process itself. In terms of existing buildings, there's very little that can be done because the carbon is locked into that building. But maybe we can make sure that building can be reused, and hence we're not releasing that carbon and then having to use it again. Operational carbon is more about the energy use of the building, the electricity, the gas, other heating and cooling, and that can be influenced by various green forms of energy, wind energy or photovoltaic. And it is very much focused on the type of energy that's being used and also the amount of energy that's being used to operate the building.
And we have, for the past couple of decades, paid a lot of attention to operational energy use, meaning to operational carbon through a lot of energy efficiency efforts, especially targeted towards buildings. And also as we move forward and the energy grid decarbonizes, as John mentioned, perhaps different renewable sources of energy come into play, that operational carbon will start to reduce over time. Embodied carbon, on the other hand, really is something that's spent and stuck in those materials that you've used. In an existing asset, you could probably still have some impact because every building over its life has some interventions. So you may change equipment, you may change the roof, you may do other interventions. While doing those interventions, you should still ensure that embodied carbon is one of the decision-making points that you consider in those design and construction decisions. Also, we need to understand that these are still not two separate things. They're interconnected. Embodied carbon and operational carbon are interconnected. You may consider perhaps an envelope system for your building and look at its embodied carbon and its operational carbon. You may look at an alternative or a new option, which may provide a lot of efficiencies in terms of operational energy use and therefore operational carbon, but it may be very high in embodied carbon or vice versa. So they're interconnected over the life of the asset. Therefore, we still need to pay attention to both embodied and operational carbon.
When you talk about embodied carbon, are you talking about it in existing buildings, and is it therefore often a recycling issue? Or is it you talking also about embodied carbon that's already in materials such as concrete and steel?
It's really both, I think. So, for example, steel and concrete use a tremendous amount of energy in their manufacture, and that carbon is locked into that building. But if it's recycled, that's releasing the carbon, and more carbon is going to have to be consumed to replace it. So a large part of our focus has been on trying to reuse buildings as they are, rather than just demolish them and start again. It might be very much cheaper to heat or cool a brand new building rather than an existing building. But if you look at the overall aspect of carbon use, embodied and operational, it might be far better to refurbish an existing building.
If you could elaborate a bit more on the vision and explain how it would work. One question I have about that, for example, is what does a digital twin add that you couldn't just get from some other types of digital transformation, other existing tools such as computer-aided design, 3D modeling, and Internet of Things?
The first thing I would point out is that you're talking about 3 additional tools which are not necessarily compatible. Computer-aided design, 3D modeling, BIM, Internet of Things. They're 3 different and siloed technologies. With a digital twin approach, we are very much focusing on digitization of very much a paper-based culture within our world of construction. Even though we might not use paper, we're still using paper-based documents and PDFs and operations manuals. And that really precludes a structured data approach, having the data available in the database in a standardized form. So we have a very big focus on standards, because if we're not all speaking the same language, and the language of digital twins is data, then we can't collaborate across the architects and the engineers and the general contractors and the trade partners and the owners, of course, right the way into the ability to then to correlate all of this data, and for the owners to start applying artificial intelligence or machine learning to get insights into how that building is performing. Our focus is very much, let's not talk about the silos of technology, let's integrate those through a transformational approach into a single, what we call a digital thread approach, to enable digital twins, to enable value to be unlocked through use cases.
To me, digital transformation is at the organizational level. So you are a developer organization, you apply principles of digital transformation at your organizational level to every aspect of your business. It could be HR, it could be accounting, and so on. Digital twins, on the other hand, do the same thing, but at the asset and portfolio of assets level. They provide that holistic approach to using digital tools in a much more connected fashion. So what we learned from our journey on using 3D and BIM is now we can overcome some of those deficiencies through this digital twin approach, because it's centered around data, it's centered around information management processes, and really takes this integrated, interconnected approach to our working that's very helpful. And one of our authors, in fact, talks about what's called awakening the sleeping digital twin. So most assets have some shape or form of a digital twin. We don't realize it. Once we connect those systems that are already in an asset in a much more clear and systematic fashion and connect it to the performance framework, we get a digital twin. And that's how we bring about a fundamental change in how we approach assets, especially during their use stage.
The white paper says that 5 user guides are coming that will provide some practical details on implementing digital twins for this purpose. Why is it important to provide guides on those particular topics? And if you could talk a little bit about what they cover, that would be great.
I think the first thing to point out is, Anil said that this has to be a practical guide. There's a lot of organizations calling for the fact that this has to be done, but nobody's really telling the market how it should be done. So we want to provide a practical guide from our own experience of how to do this. The guides focus on 5 things. First of all, to answer the question why we should do it. And that focuses on things like sustainability and efficiency, resilience, health, risk mitigation, performance, reliability, and accountability, all the important outcomes. The second guide will focus on the identification of the stakeholders and how they should participate, how we recommend that all stakeholders participate in solving a problem which is not just a problem for building owners, but is one which everyone on the planet shares. Thirdly, we want to make recommendations into how the overall building life cycle has to change in order to adopt the benefits of a digital twin, a more digital approach. Next, we want to look at the project delivery process. Project delivery processes are not very collaborative at the moment. So we want to recommend more collaborative processes which will support the fifth area, which is the creation of that digital thread, that ability to communicate between all phases and all activities within each phase in order to provide the foundational information which is required by the digital twin.
Part of the working group, we have lots of experts who helped us with their, we had a lot of working group sessions and inputs and reviews from them. So it became very clear that it is important to provide the implementation steps. If somebody is convinced by the call to action, then what are the steps they should take? So we provide in those 5 user guides, high-level principles and implementation steps that are practical, that are real world, and can guide the implementation of this approach on any asset that a project team or a stakeholder group may choose.
Can we drill down a little bit into digital threads for a minute? Can you talk about the role they play in the digital twins and specifically what's involved in creating a digital thread for sustainability purposes?
Well, first of all, I would say that although we talk about a digital twin, it's very rare within a digital building life cycle that we will have a single digital twin. We could have a planning digital twin, a design digital twin, construction, procurement. There's multiple digital twins, all of which are addressing a particular use case. But unless we can start to link all those digital twins through shared data, then we're not going to have a very efficient process. So the digital thread is really the ability to link the planning phase with the design phase, with the construction phase, with procurement, with operations, and then back into the revamp retrofit phase. And doing it not through the passage of paper or pseudo-paper documents, but through actual information which can be passed on very quickly from system to system, from group to group.
The way I explain it in very simple terms is, let's say you've got a new single family home and the builder just gave you the keys to the house. So you get the physical possession of the physical asset and nothing else came with it, or perhaps some manuals in a kitchen drawer. The other approach could be a digital twin approach where alongside the key, you also get an app on your phone which gives you all the information about the systems and components in your house. You will be able to then, perhaps in troubleshooting situations, quickly not only see physically what the problem is with that component, but also go through that app to trace exactly what component is causing problems and gather more information about it and perhaps call the right people to come and take care of the problem. To get that second scenario to work, you really need a digital thread that takes the data and the information about these components and subcomponents from the design and construction stage to the handover stage and keeps it connected through the concept or paradigm of digital thread. So if you had these digital threads of the whole system, of the whole asset, it becomes part of the digital twin and helps you integrate and connect all the pieces of data and information that need to be connected about various parts, systems, and components in the asset.
In a previous paper, we've discussed the fact that the digital thread has the concept of length. So the length could be from planning all the way through operations or even through the infinite life cycle of a building, but also the concept of a width of a digital thread. So if we build the digital thread around an asset, say we can have a pump going all the way through from design into operations, then we can start to add data around that pump. So attribute data to know warranty information, serial numbers, manufacturers, at the maintenance information, parts information, performance information. We can tie it back into sensors. So the digital thread is something which is multidimensional and will evolve as the sophistication of the organization evolves.
And in the fifth user guide, we have specific implementation steps and recommendations for enabling a digital twin through a digital thread.
Helping people to take action and using digital twins as a tool in that is maybe the primary goal here. But in the paper, you also mentioned that the digital twin can be leveraged for corporate compliance and validation of ESG standards, codes, ethics, et cetera. Can you elaborate a little bit on how digital twins could help with that effort, which is becoming so prominent in organizations today?
The first thing is that in order to report ESG compliance, data has to be collected from multiple places in the organization. In a lot of cases, that is entirely manual. For example, in electricity supplies, meters will have to be read, or electricity bills will have to be correlated in terms of the total energy use. With a digital twin, we can monitor all the meters automatically, correlate that data with full audit history to make sure that data is being reported accurately. But the most important thing is that compliance in reporting is one thing. The focus of our working group, our task force, was more on how do we actually change? How do we improve the performance? So we don't want somebody to just say, this is what I'm doing, and this is the energy, this is my carbon footprint. We want them to be able to report period to period that they are improving that performance. And so unless we can correlate all the different causes of that energy use and suggest energy conservation measures around the ESG reporting, we're never ever going to improve the performance.
And we see this reporting as a byproduct of the work that we are proposing, the call to action and the user guides. It is not central. It would come if you had a working performance-based digital twin for your asset. You can do summary reports, compliance reports, or very detailed reports because you will have all the data. So while it's important, it's not central because it's the performance and its improvement that is crucial in our view.
It seems that there's a growing awareness nowadays that any IT-based solution to a sustainability problem should be analyzed for its own environmental impacts. Have you considered the environmental impact of digital twins in these applications? And if so, how much do they maybe add to the problem of carbonization?
I would say, first of all, that we have such endemic waste within our construction world, within the built world. I saw one estimate recently that 20% of all our building materials are wasted. So that means if we can improve the performance, we can build 5 buildings for the same material rather than 4. Any use of IT or computer energy, I think, is going to be more than offset by the fact that we can do a lot more with the resource that we have available.
So while we haven't measured it, but I think intuitively, it seems like we'll have a net gain. And many buildings already have some of the things that you would need to get a digital, an existing asset would have some of the systems already in place. So that additional layer or effort that's needed may not be that high to bring everything together and deploy a performance-based digital twin.
I heard from one owner recently that they estimate between 3 and 5% of the construction costs were having to be expended on top of construction to gather the data that they needed to operate the building. That data should never have been lost in the construction process. So anything we can do with a digital twin or a digitization process to keep that data gathered together is going to produce immeasurate benefits into the owner community and into the total carbon footprint.
What kind of commitment in perhaps support and maintenance and maybe even additional technologies such as analytics, maybe more networking technology, should organizations expect to have to put into place, or at least have already, if they want to use digital twins to try to decarbonize their built environment?
I would say most organizations already have the infrastructure in place, but they're not necessarily using it to the maximum effect. There are still issues to be solved around changes made to the building as we go through tenant improvements, retrofit and revamp. And we still have to address how to bring a lot of these processes to the existing built environment as well. We don't have all the answers yet for some of those areas. Probably one of the biggest issues that we're having to solve at the moment is an organizational issue of sharing information from the operational technology, from the sensors, through information technology networks, where all the sensitive information of a corporation is being shared with the information coming from sensors. This is really pointing to the fact that we might be building out a complete virtual model independently of the IT infrastructure, because the risks of running both of these systems, the internal business systems and the building related digital twin on the same infrastructure, is maybe too risky from a data security and other aspects. I think some of these problems still have to be solved, and I'm sure Anil will have some opinions on that as well.
Definitely, I second what John says. I think the biggest enabler to overcome some of these obstacles is a disciplined approach to information management processes. So you will notice that our sector has started shifting from saying building information modeling or 3D modeling, because that's not the real intent. The real intent is to improve our information management process. When a component or a part is put into a building, we've got to make sure that there is a digital thread that will store all that information over the entire life cycle, and all decisions made related to that component are also stored, and they can be utilized downstream over the life of the asset by any person or entity who's authorized to get that information and use it. So I think perhaps focusing on improving our information management processes will change several things, including overcoming perhaps cultural and mindset issues. I think we also talk about changing and shifting the delivery process of our assets in the paper. We talk about perhaps rethinking how we procure, how we put our contracts together when we currently operate assets, deliver assets, manage assets. So there is a need to consider that as well. But I think central to all of that would be improving our information management processes.
In the white paper, you recommend establishing the new role of owner performance advocate to manage the digital building lifecycle in parallel with the owner representative who manages the initial stages of the conventional lifecycle. Can you explain why that role is needed and how it might come about?
The conventional process focuses on delivering a physical building. We now need to focus on delivering a virtual building as well as a physical building. And that virtual building, which is the digital twin, really comprises the two parts, the simulation model as well as the performance model in terms of how it's actually performing. So unless somebody is managing that process, we're going to get to the end of the construction process and have to go through a very different process to building that out. We have the owner performance advocate in place. They're going to be focusing on making sure that building is going to perform in the virtual sense and aligning that virtual performance back to the physical, and ensure that the new perspectives, not just delivering a physical building, but delivering a well-performing physical building, are going to be achieved.
And our emphasis is on independent advisor focusing on the performance of the asset.
In the white paper, you and your co-authors also wrote that there needs to be a total shift in mindset and culture, a shift to a regenerative, circular, low-carbon mindset with continuous improvements and interventions necessary. So that sounds really ambitious. It sounds like a lot of what societally we're trying to achieve, many of us. Unfair to ask how we can get there, I guess, but what do you think are the keys, 2 or 3 keys to succeeding in this very ambitious effort?
I think a lot of the detail of that will come out in the 5 user guides. But from my perspective, I'll give you the analogy of an orchestra. Unless you have a conductor of the orchestra that's made up of multiple different parts, somebody who's controlling the overall process, then that orchestra is going to make a noise rather than music. What we're doing within our construction life cycle at the moment is to make a lot of noise. We'd like to turn it into music, the equivalent of music, by enabling the owner to take control of this. As far as I'm concerned, we need the owner community or the proxy of the owner community, which is the owner performance advocate, to step up and to conduct all the different parts of our construction life cycle in order to make sure they're all very much focused on the reduction of carbon.
David, what I'd like to say to that question is really, I think much of it is already happening. I think decarbonization is a lever that has got a lot of people's attention. So there are things such as material substitution, better use of materials, reducing waste. All of those things are happening. And perhaps what John said, they may be happening not in tandem, not in a connected fashion. Our goal is to make sure that they all are connected and they are driving in the same general direction, so that we can have that music that John talks about. So it may seem challenging and difficult to get that kind of change in our sector, but I think it is now possible, seeing what's happening on the decarbonization front, addressing the climate crisis, which has become very crucial in the built environment sector, as I said in the beginning, is a very crucial part of the whole effort to decarbonize the economy.
What do you think will be the biggest obstacles, especially from the point of view of the effort that you are part of? I know you're part of a bigger effort, I think, in your industry and in your professions, but this digital twin effort and other ways of using information technology for decarbonization, where are the obstacles right now that you see, or maybe in the near future?
From my perspective, I would say the technical obstacles have largely been removed. And so the existing obstacles are now more organizational or legal. So we still have a focus within our design construction legal system of the architects providing design intent, of the general contractor providing means and methods. They both use a building information model to do it. But at the moment, those models have to be separated, and there's a lot of waste in terms of duplication of effort. If we can start to focus on the organizational aspects and to align them with the legal aspects to allow organizations to become more productive through that life cycle, then I think we'll make far better use of our existing technologies.
And I think another way to look at it is also that we need to start taking a whole of life or life cycle approach. Most of our projects, when we are in the project stage for a new asset, we would generally look at the first cost and consider a low-cost procurement approach. But I think if we have to accomplish this decarbonization and other performance-based outcomes from our assets, we'll need to take a whole of life, a whole of asset, and a life cycle approach.
Well, John and Anil, this has been an interesting discussion. I really appreciate your time today.
Thank you, David.
Thank you very much.